All right, so today we're going to deal with section 3.5, functions and relations. We're going to look at functions first. And what I like to use for definition of a function is for every x, there is only one y value. Or for every input, there is only one outcome. So let's look at this. Also realize that functions, the x values will be the independent variable. For every input, that's the independent variable. And then the solutions, or the answers that you get out, will be the dependent variable. So the y's are the outcome. And example 1, functions defined by tables determine whether each table expresses y as a function of x. Meaning, for every x, it only has one y value. So question A, from 0 to 10, the cost is $4.60. So if I choose x equal to 5 pounds, if I say x equals 5 pounds, my y is only $4.60. If I say x equals, let's say 31 pounds, my y is $32.90. So no matter what I put in for x, I only get one outcome. So this is a yes. The next one, if I let x equal 5 pounds, my y is $4.60. That goes 0 to 15. But when my x is, when x equals, let's say, 11 pounds, 11's in this one and 11's in this one. So my y values are $4.60, or it could be $12.75. So since when x equals 11, I have two y values, this is a no because I have two y values. So that is not a function. That does not express y as a function of x. All right, let's look at the next one. When x equals 1, y equals 1. When x equals -1, y equals 1. And this is all okay because when x equals 1, I only get one y value. When x equals 1. The y's you may end up with y twice, but x is -1 and y is 1. So that is okay. So this is a yes. Relations given as lists of ordered pairs. So this is that relation when you just have relations, ordered pairs. Here we go. So is this relation a function? So when we operate the same way with these, when x equals 1, my y is 2, or my y is 5. So when x equals 1, I get 2, 5 for the y, so this is a no. Next one, when x equals 4, we get an outcome of 5. When x equals 3, we get an outcome of 5. Still okay because when x equals 4, I get one outcome. One outcome. When x equals 3, I get one outcome. When x equals 2, I get one outcome. And when x equals 1, I get 7, one outcome. So this is a yes, a function. Now the next E, now if you have a graph, and we have this thing called the vertical line test. If we have a graph, and let's say here, look at this graph, this is a parabola opening to the left. you see that y, when x equals 4, my y is positive 2, my y is negative 2. So this is not a function. So if you can draw a vertical line, so the vertical line test said if you can draw it, you can only cross once. So vertical line can only cross the graph once to be a function. So let's look at these. Example 7, using the vertical line test. So if I draw a vertical line here, it crosses twice. I could draw a vertical line. But you can see it crosses twice, so this is not a function. This one, if I draw a vertical line anywhere I draw a vertical line, it only crosses once, so this is a yes. And then C, if I draw a vertical line, it crosses twice, so this is a no. I know if I draw a vertical line here, it only crosses once, but it has to be throughout the entire graph. All right, domain and range. And how do you remember which one's domain? How do you remember what's range? Well, alphabetically, D is before R. So domain will be your X values, which is alphabetical, and range your Y. Just a way of remembering that. So domain are your X's, range are your Y values. So in this graph here, I can see that the points are 0 goes to 0, 1 goes to 1, negative 1 goes to 1, 2 goes to 4, and negative 2 goes to 4. And my domain are my X's, and my range are my Y's. Identify the domain and range of each relation. All right, so in this one, the domain would be 2 and 4. I only list them once. And your range then is 5, 7, 3. Is that relation a function? It's a relation. This is not a function. It's a relation. All right, how about this one? Y equals 2x. So knowing what that is, that's the slope. So you have 2 over 1x plus 0. So we start at 0, go up 2 over 1. So that's what the graph looks like. I think it's easy to look at graphs sometimes. So what is my domain? Well, what can I put in for x? I can put anything in for x. So you're going to say negative infinity to infinity. And what's my range? Same thing. All my y's can be anything. So negative infinity to infinity. And that one is a function. Letter C, y equals square root of x minus 1. So let's say you want to graph that. Let's graph this thing. Oh, hang on. So we're going to graph y equals, we'll draw it out here, square root of x minus 1. Lasso that thing in there. This math. I'm going to graph in 2D. So we can see this is my graph. Let's see if I can slide this thing down a bit. It's not one of that I could move it. There we go. So I'm going to slide this thing down just so we can see the original. I'm going to shrink it up. There we go. All right, so y equals the square root of x minus 1. So I can see my x's go from here and on. So my domain will be bracket 1 to infinity, because all my x's start at 1 and go to infinity. What is my range? Well, what's my y value here? So it starts at the point 1, 0. So my range will be 0 to infinity. So I think when you're graphing something that you're not sure what it looks like, graph that, put it on your calculator and see what it looks like. All right, let's wrap it up. Functions. Now, if you have something that is, let's say, y equals that 3x minus 2, and we know it's a function, then we can use the function notation f of x. So we can say f of x equals 3x minus 2. And again, that said f of x equals 3x minus 2. What you need to know is that the x in the parentheses and the x here, those variables will always be the same. So same variable there. Question A. Find f of negative 5. So that just means put in the negative 5 for the 3, or negative 5 for the x. So 3 times negative 5 minus 2. You get negative 15 minus 2, negative 17. So f of negative 5 is negative 17, which means also when x equals negative 5, y equals negative 17. That's what you have found. All right, letter B. I want to find g of negative 5. So that means put in negative 5 for the x of g of x. So that becomes negative 5 quantity squared minus parentheses negative 5. So negative 5 squared is 25 plus 5, so I end up with 30. Which means, again, when x equals negative 5, y equals 30. And then let's look at letter C. So letter C says to find f of 0 plus g of 3. So f of 0 means I'm putting 3 times 0 minus 2. Put that in brackets. G of 3, let's put this in brackets, is 3 squared minus 3. Working that out, 3 times 0 is 0 minus 2 plus 9 minus 3. And so then I get negative 2 plus 6, 4. So that is the end of 3.5 notes.